Now we have understood the expression of limits in two different ways. We have approached limits in two different ways. We have approached the value of limit in the value of algebraic way and the value of graphical method. So there were two methods by which we have approached the concept of limit. Now if you remember, in the starting of the concept of limits we have taken one problem, that is limit x to 0 for the value of x square minus 4 by x minus 2. This was the question, and I have also said that this question is very famous, very popular in almost every book which has the topic of calculus, which has the topic of limit. Mostly it has this question. On the internet this is also very widely accepted question, because from this question you can relate two topics. You can relate algebraic identities with the topic of limits. So when I said that x value tends to not 0, right? Yeah, this was 2. When I say that the x value tends to 2, then I said that x should not be equal to the value of 2. We, in the starting of the limits, we said that there is a pothole at let us say now 2 meters. So the value of x should not be equal to 2, because when I am at this 2 meter, when I am at the second meter, I am under the pothole. I am not on the ground. The value of x should not be equal to 2. Let us put the value of 2 over here. X minus 2 should not be equal to 0. Yes. Now this is notable. X minus 2 should not be equal to 0. Then x minus 2 again, if it is equal to 0, it becomes not defined. And we have even separately learned why 1 by 0 is, or anything by 0 is not defined. Okay. So now x minus 2 should not be equal to 0. If you notice this term closely, x square minus 4, can we do some changes with it? Can we make this x square minus 2 square? X square minus 2 square. Now this is a formula, that is a minus b, a square minus b square is equals to a plus b into a minus b. Now explaining this value in the terms of the identity would be x minus 2 into x plus 2. Then can we represent this in the form over here? Limit x to 2. This would be x minus 2, x plus 2 by x minus 2. So now we find that x minus 2 is at the numerator as well as the denominator. So we can cancel x minus 2 and x minus 2. So when we limit the value of x towards 2, then we have to get to the equation of x plus 2. Now what did we do over here? This is our second equation, or let us say expression. We started with this expression limiting x to 2. This is our actual question, and this is where we have arrived. So can we say that this one and this one both are same? Yes, both are same. This is much a modified and much simpler form of the same question over here. Okay. Now what did we do actually over here? We reduced it from a quadratic form, that is like square form or square power, to a single linear power. Okay. Now when you are decreasing it to a linear power, we have learned the concept of graph. We have learned the concept of straight lines. We have tried that value, x should not be equal to 2 and x minus 2 should not be equal to 0. Okay. The equation for straight line goes as y is equals to mx plus c. So can we plot the value of this equation as a graph? Yes, we can of course plot it as a graph. So let us plot a graph over here. The question over here actually is, what would be the values of x? What are the values of x? What values of x can we put in this equation to make it satisfy? So let us draw the graph as said. Y is equals to mx plus c, where m is slope, or where in American or in other countries we say it as gradient. So m is the slope. Here what is this value of slope? It is 1. It means the line will be at 45 degrees. Okay. This would go as per 45 degree. And c is the y-intercept, which is plus 2 over here. So this will be extended till here, plus 2. This is the graph. This is the graph of x plus 2. Yes, the point to be noted is this is the graph of x plus 2, but we don't need the graph of x plus 2. We need the graph of limit x to 2 of x plus 2. Now see here, let us plot the values of x. This is 0, this is 1, 2, 3, 4, this is 1, 2, 3, and it goes on. The thing is, we have noted here that the value of x should not be equal to 2. So x value should not be equal to 2. Then here comes the concept of intervals. Basically, intervals is actually separately a very huge, a very vast topic, but for a reference, interval, if you've seen a movie or something, interval means break, right? A break. So, in graph, interval is expressed by an open hollow dot. So what we do is, at a point 2, we put an interval over here, which goes something like this. What does this state? This states that the value of y at x is equals to 2 is not defined. Okay, the value of y at x is equals to 2 is not defined at all. Why? Because we know from the value of from the idea of limits that x should not be equals to 2. So we put an interval over here, and this is the graph which we plot for the limit of x to 2 of x plus 2. What is the question? What are the values of x? So the value of x can be any real number, or it belongs to a real number which lies between closed interval minus infinity to 2 with an open interval union 2 to positive infinity. Now what is this? This is a mathematical term which is this is called as union, which means addition of two separate sets, and closed interval means that the values are not included. And so these are open intervals. Open intervals means the values are not included, and closed interval means the values are included. So over here, this is the limit, which means that the value of x can reach anything from minus infinity to 2, but not 2. It means it should not be 2, it can be any value which is close to 2, and it should not be equal to 2, and it can reach to infinity. So this is the answer of this question. So I hope you have understood the concept of limits. Now actually what we have learned about limits is a very small proportion, but a significant proportion. We have understood the actual idea of what limits are, and now we can continue with our calculus for the limits. Our main goal for this series is to complete the topic of differentiation or differential function. So for understanding differential function, these were the limits which is necessary. We won't be going for more limits because there are much advanced problems for limits which involves cubic equation, logarithms, etc. But we are stopping over here. Now in the next video onwards, we will start by the concept of stroke towards the concept of differentiation. So I hope you are enjoying this series. If you are enjoying this, do subscribe to the channel, like to the video, and comment if you find anything interesting. See you next time. Thank you and goodbye.